Eldritch, hey, welcome in. Ever see, was it Dan's chat? I definitely remember seeing you somewhere. Spetry, hey, I know, you got beaten. Because the Germans got one additional first. Team Germany. That'd be a fun, like, tracker, too. As people would have to say what country they're in. Does music might need to be turned on slightly more. Up on YouTube? Alright. And Eldritch, if you do need any help with the question, please feel free to let me know, or anyone needs help with the question. If not, I'm just gonna look around for questions on the interwebs. And then if I don't find any easily, I'm gonna just find some multivariable calc. Was there something that I meant to do? Oh, you know what? Okay, I feel like I just have to like show off a little bit. I set up something that I think is kind of cool. Let me take the webcam down, and then if I do set problem, I don't know, pee pee poo poo, it shows up on the on the screen. I don't know. I feel like it's the coolest thing. You can make a chat command and actually like interacts with the stream. So I did have to make it mod only because I feel like that could be abused, but oh, are you out of here, Eldritch? If you are, then hope you have a good night too. Yeah, see, it actually like it shows up there, and it's super quick too. It's always so annoying to like when if someone types out the problem in chat, it's really hard for someone who comes in later to see what the problem is. And pinning it is nice, but sometimes I feel like actually having it on the screen is better. Hey Ben. Gotta get that meth. Okay, the show problem works too. I don't remember if I actually even tested that. Hey, Doomod. Hey, Jed. Um... It's not gonna be much here. You saw me on Zach's stream last night. Did you not raid Danny with us? Wait, well, I'm getting confused on who's who. Wait, who? Okay, Danny Highway was streaming first. Danny seemed a bit off yesterday, almost angry. um. Oh, you're right. Zach was streaming first. I was there for the raid, but I added on in the background and quiet, or like kind of quiet, because like right as it happened, my friends asked me to play Apex, and I didn't want to say no. So I was like lurking, but I wasn't able to fully pay attention. Oh, this person could use the good word of Paul, I think. Oh, wait. Well, yeah. Yeah, Jet. So if you want to try them out, please do. But I think it would be nice if someone types the problem out in chat. We can actually have it up on screen now. So you do exclamation point set problem text here. Unfortunately, I can't make it like I can't like I was debating if I want to make the text box go all the way to the bottom or not. I feel like it's better in case there's a long problem. But I can't make it like dynamically update as far as I can figure out at least. And then hide problem to put it away. There's also exclamation point show problem as well if you don't want to like reset the problem text. Hey Krim, if z isn't 0 and 2 plus cosine plus I sine theta equals 3 over z, find the value. Oh, hey, this might be the perfect place where we can test out our set problem thing. There you go. Oh wait, why didn't that? Oh wait, no. Set problem sketcher, not show problem. Yeah, but like that. You're getting beaten to everything today, Spetry. Z prime represents the conjugate of z, and absolute value of z represents the modulus of z. Okay. I assume we want to get this into exponential form. I'm not sure how to do this off of my head, Krim, but let's play around with it. I can manually crop this text box the same way I can't manually crop this text. No, I can. Oh, it's really weird though. Oh god. Wait, how do I get it back? I do it like that. Okay. That's super weird, but okay, I technically can crop the box manually. So let's... I don't know the perfect technique to do this, Krim. So I'm gonna kind of play around with complex numbers and see if I can make it work. There might be a better way to do it that I'm not seeing, or something in general that I'm not seeing. So if that happens, then my bad. But my instinct is to put this into exponential form. 2 plus cosine theta plus I sine theta to find the value. Wait, sorry, is equal to, what was it equal? 3 over z? Yeah, 3 over z. I guess I'm copying the problem too. Yeah, so I think it's not necessarily the same theta though, is it? I keep going on like 2 different trains of thoughts. 2z plus z prime. Oh yeah, no, you're completely fine. I was like asking that like more as like an honest question that we don't. Or that like I wasn't sure. So if we take z equal to re to the I I guess we'll say phi. That's another thing that is often used for angles. That's not theta. What does this equation become? And that can be, that's e to the I theta. Right? This might not even... This could work. I don't know. Or do better solve this for z? I guess maybe that's what we're kind of doing anyway. Maybe we want z equals a plus bi. Am I already doing something wrong? Oh no, Ben. Okay, you're just memeing. Unless you see what to do is problem, Ben, but I assume you're just memeing. It's like from here, I'm not really sure like what actually happens. But isn't cosine theta plus I sine theta? Well, that's e to the I theta. If phi were a person, would z plus 1 be considered a Riemann sum? What? Oh, I get Riemann because it looks like it looks like the first part of Riemann. There are no complex numbers clearly wrong. Hey, Emster. You possess another wonky question if you want to look at it? Yeah, sure, Emster. I'm working on this other one from Krim in the Twitch chat first, but after that, I'm happy to look at yours. Hopefully there's no typo on it from your professor this time. So, I don't know, okay, well, I'm gonna leave that like there with the exponential form. Maybe let's try taking z equals a plus ib. But then what do we do with the cosine theta I plus I sine theta? I might need to Google this, Krim. I feel like I'm gonna go on the wrong. Or I feel like I've already. I'm going on the complete like wrong foot here. That would be too laborious. Oh no, I'm sorry. I'm just like making a joke too. So yeah, physics based. Yeah, it depends on the physics, but I don't mind at least trying it. Am I overthinking this? I might be overthinking this. Okay, let me back up. What if we just solve this equation up here for z, and then we plug it into this equation? So I think we can do that. So z is going to be equal to, oh, I guess that's, well, we can multiply by the conjugate of the bottom. Oops, that's still plus. I really don't know where this is going, but the problem didn't immediately come up on Google, so we might be on our own for this one. But I'm thinking like if we can get z into some kind of like form like this, then maybe, just maybe this is possible. Minus I squared sine theta becomes plus sine theta, right? Sine squared. Hey, intelligent. It's good to see you. It's some weird complex numbers stuff. That's what it is. And I have like a 1% idea of what I'm doing with this problem. Let's multiply out that plus 4 cosine theta cosine squared theta plus sine squared theta. So we just get like a Pythagorean identity on the bottom there? And we might not need to simplify this thing fully. We just need to get it enough so we can get z conjugate and z modulus, whatever. Cosine squared plus sine squared is 1, so we get 5 plus 4 cosine theta. So technically we can get the conjugate and the modulus now? I feel like I'm missing the point of the problem. Hey, Viv. Thank you for the headphones compliment. It's posted there now. It's the last question on the revision exam. All right, sounds good, Mr. So yeah, Krim, I'm really spitballing here, but I don't think I've done anything that's invalid. I guess let's see what z plus z conjugate. I mean, z plus z conjugate is just 2 times the real part, isn't it? And then there's another 2 in front of that, because if z is, oh my god, I can't write. Just a completely separate side calculation here. If z is equal to a plus ib, and then z prime is a minus ib, then z plus z conjugate is 2a, and the ib's cancel, right? So we can just take twice the real part and then multiply it by 2 again. Okay. I guess for clarity, I'll split this up into the real and imaginary parts. I didn't actually do that, did I? Formally. Or like explicitly, it's probably a better word. Like that. So I'll just pray that this isn't too disgusting of a thing to calculate, I guess. So I'm going to take 4 times the real part, because the two out there and the 2 from in there. Actually, I'll copy that back down to be explicit about what's happening. Z plus z prime minus absolute value z squared is equal to 4 times the real part. Because I don't know like what we do with the thetas, aside from just leaving them in the problem. Now we're going to minus equals 2 times the real part of z. Oh, okay, yeah. And then you're saying z times z is equal to the modulus of z squared. So we can just do z times z there, is what you're saying? I guess we can. I don't... This is going to get a little bit ugly, I guess. want, wait, the modulus of z is root a squared plus b squared, right? If z is a plus ib. So if we do the modulus of z squared, we just get rid of the square root? That seems like it's in conflict with just... But then if you do this, get a squared minus b squared plus 2a or I 2ab. That's not the same as multiplying. So I'm confused with how that z times z thing. Oh, z conjugate. Never mind. Hey, then that's right. Okay, yeah. Fair enough. Okay. So yeah, z times z conjugate, but it's basically going to turn out to be just that squared plus that squared minus that squared. Let's be safe. A plus ib times a minus ib is a squared minus turns into a plus. We already have a minus out there, though. It doesn't make a difference because the other one, that is will become a plus. Okay. So no matter what the sign we start with here, it's always going to be a squared plus b squared. Okay. Sorry, I just need to like justify that to myself for like how that sign changes. So it's going to be... Do you know if it's expected to get just like one complex number for an answer, or is something in terms of theta okay? Because this isn't a particularly nice problem, I don't think. I guess we've got... Oh no, it's 3 cosine. Yeah, that's a little on the disgusting side of things. The answer is an integer? Oh my god. Oh, sorry, I forgot to mute my mic when I drink that. How do we get an integer out of this? Surely we must be able to figure out what theta is then. Or the theta somehow cancel out of this, but I don't see that happening. There's a problem with the problem. We have 2 unknowns, z and theta, and only one equation. That's what I was wondering, Benbox, if we do know that z is on the same angle as cosine plus I sine theta. Because this seems a little hard if if you don't know they're equal, the only thing you do is hope that the thetas cancel. So I guess Phobos! thanks very much for the raid, Storm. Hey. Oh, the rest of your stream was good. That differential equation was super fun. I was kind of bummed I wasn't able to look at the matrix solution that you were working on. But yeah, for anyone who isn't already following Phobos, please do. It's an awesome stream over there. So I was just in there myself before I started up the stream over here. So yeah, we're working on this complex number problem from Krim in chat. We didn't finish, you explain the method. Oh, okay, nice. If you fumble through tons of problems. Yeah, if you're a fan of fumbling, then you've come to the right place, because I'm doing the same here. We've kind of come to like a bit of an issue with this complex number problem where I think we have to make some kind of assumption about the problem because we may not be given enough information to solve it, because we have kind of an issue where we have one equation but two unknowns. And I was hoping to get some kind of cancellation of thetas would go away here. But from my last line, it doesn't seem like it's going to happen. So right, Storm, we use that. Oh gosh, Bio, that's gonna be some weird trig trick. I gotta work on this problem that's on the board though. A problem from Emster in the YouTube chat, and then I can look at that. Calculation mistake? What happened? Come on, YouTube chat, rise up. Hey, Anders. Second line? Oh, I didn't put the 3 in front of the sine theta. I mean, okay, that might save us? It might still be in the same predicament, though. You're right, I did absolutely forget the 3 that's here. So now we do get a Pythagorean identity in the numerator, I guess? So maybe it's now worth pursuing this a bit more? Oh god, Bio, I hope I can. That's what I've been struggling with, Anders. I've been treating it as an arbitrary angle, and I'm hoping that it cancels out. I guess let's try multiplying out the numerators here. Okay, so I'm going to do a lot of this mentally. We're going to get 36, which is always dangerous when I do mental math. 6 times 3 is 18. 18 times 2 is 36. Oh, that's convenient. Oh yeah, it is a perfect square, isn't it? Okay. Cosine theta. Then we'll get 9 cosine squared theta and 9 sine squared theta, which is equal to 9. Can drop the brackets now. It's this, wait, 45 and 36. Oh my, we get a cancellation here. Oh my, does the theta actually cancel? It's gonna be a Christmas miracle if it does cancel. Because that's gonna be 45, that's gonna be 36, so we factor a 9 out. Get 5 plus 4 cosine theta. Oh my god. Okay, cosine theta squared. So now they're going to be on the same denominator. We have a 9 on top. Is it? 24 minus 9, that's 15 last I checked. Plus 12 cosine theta. If you factor a 3 out, you can factor a 3 out. Oh my god, it cancels. Santa does exist. I don't know why I'm making it about Christmas, but this is 3. Oh my god, dude. That's crazy. Theta does not even matter. You put this garbage roll from alpha and it simplifies to 3. That's why, I guess. Oh, that's kind of amazing. So yeah, I guess what we're supposed to do, Krim. Let me know if you have a question. I'm glad I was able to fumble my way to the end here. Let me put my mug away. Okay, and I also don't want to keep Emster waiting for too long, and also Bio waiting after that. So it's like Storm has found an alternate way. Do you think the use would cancel out their enders in the same way they canceled out here? It'd be nice if they did. They'll probably save us some rating. Typical having me wait. Yeah, Emster. The Irish get last priority here. So, sorry, you know. I don't make the rules. I just enforce them. At least on my system, but it seems easy. So it looks like Storm was finding an alternate way. I think I already got to the answer and I don't want to test my luck. So I have a separate bathroom a few decades ago. So was that? I don't think it was a thing for the Irish, at least not America. Either way, I don't see anything from Krim, so let's You have another problem? You haven't tried it properly? If you don't mind, maybe let's give it a try, because or at least let me take inventory of what are the problems we have in store here, because I want to see what Emster has. And if your problem is short, I'll try and get to it first, but otherwise I'm going to do Emster's, and then you're going to be after Bio, I think. Oh, okay, I'm curious to see that, Storm. Can you try the problem first? All right, thank you. Anders, it's going to show up. Oh, it's underneath the other browser. It is 80s synthwave music. Hopefully it doesn't stutter when it's through a YouTube video like this. I hope it doesn't. I think the issue is the thing that I was playing it through. I mean, I'll put the link in chat, although I don't know if you're asking because you want to listen to it. Okay, so let me see. Storm is saying to put it as a function, cosine. Oh, it's going to be a constant function, isn't it? Based off the solution I got. I don't know what to look for here. The roots are 1 or 3? Oh, maybe 1 is a trivial solution? I don't know. Should say it's 3, not 3 fact. Oh wait, I didn't put 3 factorial. Unless you mean for the problem that you posted, Emster. And I think you're talking about the thing that I did. I don't think I did 3 factorial at least. Function will be constant, the expression... Oh yeah, for the exact thing with the conjugate, like, you know, 2 times z plus z conjugate. I missed the joke. Oh, okay, sorry. But let's see what your physics-ish problem is, Emster. I assume we start with this one. Yeah, thanks, Krim, for the problem. The friction is then modeled... Oh, wait. Is it? Yeah, this looks like we start with this one. The friction is then modeled as being one continuous force with a coefficient... Oh, we start with the other one? Okay. Oh, there is a 3 there. Okay, you're right. I don't know how to count. Okay, a box of mass 25 kilograms is sliding on a smooth surface with a speed of 20 meters per second. And it encounters a rough patch with a frictional force function 12 minus 2x over 35 newtons, where x is the distance in meters the box has traveled in the rough patch. Find the maximum distance that the box can travel in the rough patch. Interesting. So, yeah, I definitely... Force is equal to mass times acceleration. If this problem was, if the box did weigh 35 hamburgers, and I don't know who that is, but if this was measured in hamburgers per second, I would have a much easier time with this problem. Yeah, you're getting some very mixed reactions to physics here. So, are we going to equate the force? No. Yes? This is gonna... Ooh, I don't think it's gonna be, like, that hard of a problem, just getting the setup right. Oh, it's Taylor Swift's husband? Oh, I didn't even know that. Ooh. Is that a differential equation, Krim? Yeah, I guess it's a separable differential equation. Yeah, I think I can do that. Oh wait, no, you're talking about this problem here. Never mind. V dv dx equals 12 over 25 velocity times... Oh, wait, oh, dv dx. That's not velocity necessarily. That's change in velocity or change in position. Huh. Oh, I think I see where that comes from, though. Okay. It's an equivalent expression for acceleration. Yeah. Actually, where does the extra v out front come from, though? Oh, that's where it comes from. Okay. Just connect energy equals work. Okay, let me follow Krim. Start with part 1. Yeah, I guess that's chain rule. Yeah, that's basically something that's basically what I was trying to search for, Krim. I just couldn't like quite figure it out before you did. So thank you for saying that. Because I think it'll be a pretty simple calculus problem. It's just doing the physics setup part that's going to be kind of hard. That might just be all the setup we need, though. I'm not sure. Because we're going to want to integrate it. Okay, bye markers. I didn't want to talk to you anyway. I think Cream even said to integrate it. Okay, I guess it is going to be separable to differential equation, though, right? Yeah. Okay. So we have f of x is equal to 12 minus 2x over 35. What's relevant up with physics? Yeah. This is applied math in Ireland. Yeah, I mean, I did some physics thing for my applied math stuff, so. Hey, Bode. You don't have a pen, B thinks process works, differential equation is separable. Yeah, I don't see a fault in what you did, at least. So we know force is mass times acceleration. The mass is 35? No, 25. Yeah, like I remember doing differential equations with like pendulums and or pendula? And like springs and masses and all that stuff, so. Also, I'm thinking about trying to study physics more. So I think I should just kind of know it. At least more than I do, which is almost none. All right, so we know that A is dv by dt, and I guess by chain rule, Krim is saying that dv dt is dv dx times dx dt, which I don't see a problem with, I guess, because we want how far it goes for a given initial velocity, so dv dx isn't a bad idea. Yeah. We got Dijkstra's algorithm, though, so it's torture. I remember having to do Dijkstra's algorithm. I know almost nothing about it. I don't remember, like, anything about it, though. And dx dt is the same thing as v, so dv dx. Okay, that seems pretty solid to me, Krim. What's 25 times 35? 5 times 5 times 5 times 7. So 125 times 7. What's 125 times 7? 700 plus 7 times 25 is 875? Do I get a QED? Oh no, it's 775? Wait. We have technology. $875, let's go. So my mental math was right. Okay. And so yeah, now we can, it's a separable differential equation and we can integrate it, I guess. Well, I mean, I'm sorry, if you do math, you have to show off your mental math skills. You solve the differential, the second order differential equation of a damped pendulum mass, we can class those really fun. Yeah, I agree. So, oh man, what do we integrate? Like, I assume we need to, we set our bounds here, don't we? Like, would v go from 20, or wait, what's our initial velocity? From 20 to 0? And we're gonna flip the bounds and get a negative sign? And then this will go from 0 to like some constant a, which will be our distance? That's my guess. Your approach, Jed. If you happen to know 25 times 36 is 900, then yeah. Silver Rubik's Cube boat? Yeah, I'll do that once we have a break. Okay, oh man, okay. Krim agrees, hell yeah. Okay, I'm excited. So v integrates to 1/2 v squared. We evaluate u from 20 to 0. 12 over 25 integrates to 12 over 25x. That integrates to x squared over 875 from 0 to a. Or I mean, we can say d, because d is distance. Okay. 400 over 2 is 200, negative 200. Yep. 12 over 25d minus d squared over 875, and 0 just gives us 0. So now we have a quadratic. A really annoying quadratic. This quadratic is going to be Wolfram Alpha's problem. These problems are annoying. I'm actually kind of excited if I can actually do this physics problem. Okay, 0 equals... Actually, go to natural language. D squared over 875. Gotta flip the sign. 12 over 25d. Plus, minus, plus... Oh wait, I'm getting my signs wrong. If I'm thinking that one is positive, the last two are both minus. No, it's plus in the... Oh my god. The last two are both minus. Okay. God. Hey, Frederick. Well, we probably... 420? Oh no, that's the sum of the roots. We get that. $678 meters? That looks like a lot, right? I guess it's 25 meters a second. That's kind of fast. Ever solved the ghost cube? I don't think so. What happens if you plug in... What is this what is this function for the friction? Now that I look at it. Did I get my... Okay, wait, let me... Minus 200 equals 12 over 25d minus d squared over 875. Can you not derive and find the stationary point? I mean, we don't want the vertex here, though. Okay, same answer. Because you just said that frictional force would always be positive, so if x greater than 0. I mean, yeah, I was kind of wondering, because like very big values of x really don't make sense here. If we probably wouldn't want an x that gives us more than like 12 for the entire fraction. To find the point, it becomes a negative. I mean, that's not unreasonable, I don't think, because it definitely doesn't make sense to have a negative friction force to me. 12 minus 2x over 35 equals 0. You can do the thing for part 3, so you didn't trust your algebra. Oh, but you don't trust your algebra. 210. That seems more reasonable for the 0 point. Hey, Khalif, if I'm saying that right. Answers it in a math class, and I feel like I should be able to do it. Oh, is that the ghost cube Phobos? How? That's really confusing. Is that when it's in its solved state? When it's like, or do you have to somehow get all the yellows to align still? Oops. Should there be an expression, a negative sign in the expression of net force? I thought we took care of the sign when we integrated from 20 to 0. Just scrambling the cube right now. That's true, Krim. Right now, yeah, the friction is a positive force right now, unless we make it negative. And they're saying the negative sign makes things wonky because then there'd be even more values for x that f's things over. I mean, if we just kind of magically change this 200 to be positive, what happens? Do we get a more reasonable answer? Nope. Wait. No, yeah, okay, we get complex answers. Wait, why? Doesn't that clearly have zeros? Oh, because it's not offset, I guess? It's a parabola facing down with the y-intercept of positive 2. What the heck? Is Wolfram smoking? Oh, never mind. The y-intercept is negative 200. I don't know. Yeah, let me do this solve quick, so it's off my mind. Expecting. Oh, what the hell? I messed this up royally. Yeah, this is terrible. This F2L is taking so long. Frickin' B-perm. Ugh, terrible. But there's the solve mode. If you get a force function, the force is given in magnitude form, and you don't have to do any sign tomfoolery. Really? Did any of you get about 678? We also got 678. That just seems like unreasonably high. That's 678.01. All right, see ya, Aya. Thanks for the well wishes. So, okay, Finlux apparently used energy and got the same answer. Are we right? Okay. That seems super weird. But 20 meters per second is a lot. Yeah, it's like 20 meters per second and miles per hour. It's going 45 miles an hour. It's going to cover some distance. Yeah, I don't get how the friction is decreasing, but I guess we can accept it as true. How to be smart at math like me, Lozen? I mean, smart is relative, I guess, but just anything math that I'm good at is because I practice problems a million times, pretty much. So just keep on doing problems more or less and be okay with being confused. Part 2 is really easy, Crim. Yeah, work is force times the distance. Oh, we know the force. Oh, wait. You probably still have to integrate it, though, right? Wait, 1/2 mv squared. For the friction function, do a B whoop? Like, how? The friction decided it was having a bad day and just switched direction. Decided to be different. I mean, do we go past the negative mark here? 678. What was the 0 point? That is a good thing to check. Hey, Brandon, man, this is so Emster's in an applied math class, but this is basically a physics problem. I'll show it again in a second. I just want to check this. Actually, I'm showing it now, but I'm not going to show it for long. 12 minus 2x over 35. 12 minus 2x over 35 equals 0. When does friction become negative here? 210. Oh, and we get 678. So yeah, we're definitely going past the negative point here, aren't we? I mean, I guess there's no reason we can't. But that seems so weird. Smooth surface. Wait. Oh, but then it encounters a rough patch. You know, anything encounter a rough patch in life. If the friction becomes positive, though, how does it ever stop? I certainly don't, Anders. Said it wanted independence, apparently, Emster. Yeah, so I mean, work is the integral force times displacement. We would integrate the function we're given from 0 to the answer we got in the last problem. Physics is something that doesn't make sense. Math is much more intuitive. Depends on the person, Bode, I think. Actually, wait. I might be interpreting this wrong. It's accelerating the box at first, and then it slows the box down after the... I guess, I don't know why friction would increase the speed of the box, but I guess it is in this case. You got 258 meters integration rate parts? So that's still after the 0 point is 210, so we saw... I guess that potential issue, but I don't know what friction this is. We can blindly do the math and not question the real-world applicability of it. So integration by parts, both me and Fembox doing two different techniques got the same 678 answer. So I'm inclined to go with the answer that we got. But if we did something wrong, please point it out. Why would you not have to integrate this? Oh, use energy conservation? To me, the simple thing that I know will work is integrating it. Because I don't remember energy conservation at all. So I guess for part 2, just keep doing green. Be the integral from 0. Oh God, are we into that stupid looking radical? I guess 10 times 21 plus square root 2191. I already forgot the number that I said right there. Like that. We're going to keep things exact and be mathematicians and not physicists. Integrate will match your answers. Okay. I guess let's do it. The function for the force is 25 minus 2x over 35. Okay. Dx. 12x minus x squared over 35 from 0 to disgusting thing. And then this is going to be Wolfram Alpha's problem. And the force vector is oh, should we split up into, are you saying that we would split up into two integrals? You got the, it should be 210, Emster? Or like it matches with part 3? Oh no. Wolfram Alpha's, oh my god, it's gonna be a freaking jerk to me, Wolfram. Come on. No, stop it. It's not, I hate you, Wolfram. If I open you a new tab, will you decide to behave? Okay, thank you. Okay. I no longer hate you, Wolfram. Actually, I didn't even need to do that. I was just raging at Wolfram because I felt like it, I guess. What am I doing? That. 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 Oh, I need that in parentheses. Squared over 35. Okay, I'm sort of saying it really should be 210. Negative 5,000? That doesn't seem right. That's an exact result, though. So the work done by friction force. Oh, I guess if it's slowing it down, maybe. But apparently this is potentially wrong, because it's not going to match with the answer for part 3. So what does part 3 say? So if you have that constant coefficient for friction, that's just mu times x, if I remember right, for the force due to friction. Is it? Is it mu x or just mu? And just the normal reaction? I don't remember that. I don't have normal reactions things. Oh, wait, is that the normal force? Which is the weight, right? Then R equals mg. Okay. So it is the normal force then. Right, and then if it's on like a slanted surface, you have to do some vector work to get the normal force there. So we have to show that mu equals that. So how would you show that mu equals that? Well, I guess we would say What's the work done by friction? I assume we need that? And we would set it equal to mu mg? You can't calculate the work done by friction force. Do not use work then? Like, how would you... Put in the same chat? Oh, okay. And so this is assuming the answer to part 1 was 210. It was what you were saying. Hey Maverick, when you get live stream to the audience, well, thank you for being here. And for the kind words. I don't know what this equation is, but I assume it's something to do with friction. If this gets you the right answer, I would go with this, I guess. I wish I knew more about physics to tell you why one is right or one is wrong. It's a linear motion equation. I'll believe you. I guess linear motion with friction. Bio. We can get to your question. Yeah, because you were up after Emster, so, and I think we're nearly done with Emster here, so. See, Emster, I guess you have the right answer. It matches, so I think what you have must be good then. I don't know what's wrong with what we did, but when we're doing this in high school, you think not to ego. Oh no. You're doing like calculus physics in high school? Oh, maybe you did like AP physics. I didn't do a problem like quite this hard in high school, but I avoided AP physics. In college, for calculus-based physics, I probably didn't do this exact problem, I probably did stuff like it. This exact problem seems like kind of silly with the numbers that they give. But I don't know about physics to really rate it, I guess. All right, so I guess I don't have anything else to say about your semester. I don't know. I'm sorry that I don't have a firmer answer, but it sounds like you got something that's reasonable sounding. Let's get to Bio's terrible trig stuff. All right, sounds good, Emster. Thank you for the question. Glad to hear it. All right, so Bio, let me look at your message history. So you put a few in here, I think. Oops. Oh, I don't know why I would hold that message for review. Hey, there, Bonda on YouTube. How's it going? We got a sine one right there, and we got a tangent one right there. So that was the second one you put, and that was the first one you put. So I guess let's look at the first one first. That seems to make sense to me. Now, do we have a very easy trick here where it's like n is equal to 90 minus the other? I don't see it. You think the sine one first is easier? Okay. Just use a calculator? I think degrees is pretty safe to assume here. Oh, I wonder if you double angle it. Do we have any doubles? No? I do notice that 42 times 2 minus 6 is 78. I don't know if that's helpful. Sine 18 minus cosine 36, and that's it. Just going in circles from that point. Okay. Oh, but you're saying for the tangent one, you could break it up like that? It might be worth trying that with the sine. Oh, yeah, sine 60 plus sine 6. Okay, let's try. And then how can we do it? What's 78 minus 42? Is that something good? 35? That's not good. Okay. Let's see if we can... Actually, wait. I'm gonna cheat and figure out what the answer is first, and then we'll see if we can figure out the solution. I don't want to go around in circles for 10 years here. I think I see the... Okay, we're expecting minus a half. So these non-unit circle degrees should ideally cancel out. Oh, we can do a little, Bam! Oh. Oh, wait, you know, I should really crop that, though, right? Actually, let's put them both here. Ah. Oh, wait, that's gonna be confusing, isn't it? Too bad it's your guys' problem. Okay. I'm going with that. I can't actually put a line break in there with that Twitch command, unfortunately, so... Oh, there might be a way. I'd have to look and see how OBS interprets, like, if there's like a line break character. That could be interesting. Do like a backslash n or something. But that's it for another time. Okay. Let's do red. Does the thing do any parsing? For like that text thing, Brownie? Nah, it doesn't. It does some like formatting, but I don't think it does any like actual parsing of the stuff. Gives purpose into the tangent one if you actually get it, that you know? Okay. It sounds like Bode is putting some hints in chat. Can at least use Google for factoring. I mean, you can use Google for anything you want, Bode. As far as I'm concerned. Is sine 18, I mean, does that sine 18 minus cosine 36 thing even help us though? I think we want to get everything onto unit circle, get the not unit circle to cancel out. So we have sine 6 minus sine 42. See, I think we're gonna have to split up into like, you know, 42 is equal to something plus or minus something else, and then do a sum or addition identity. Sine 66. Did I get the signs right? Hot signs. Oh wait, no, there's a minus for the 66. Like that. Okay. Like we're good here. And hello to Ella over in the YouTube chat. Okay, so I like saying that 66 is 60 plus 6, because we might get some kind of nice cancellation with the sine 6 over there too. I don't really know what to do about the 48 and 72 though. Let's just leave them alone for a second. That is 90 minus 12. That could be helpful, because 12 is twice the 6. We're gonna get my trig identities first though. So if we're doing sine of something plus something, it's sine cosine plus. Okay. Sine 6 minus sine 60 cosine 6. Because it's minus in front, we do minus cosine 60 sine 6. I'm mixing my parentheses. Or not, but who cares? So sine of 60 is unit circle. It's root 3 over 2. Okay, this is going to be a bit harder than I thought. It's 1/2. Well, so what do we do with the 42 and the 78? Oh, nice job on that one, Bode. I'll look at them more later. Sine 78, I think we can do sine of 78 is equal to cosine of 12. Which is, I think, a helpful step. That sine 42, though, I really... Let's do the same cosine identity. I really don't know what to do with that thing, though. Stop doing parentheses. I feel like 48 is better than 42, right? Now let's do a double angle there. It's 1/2 sine 6. Cosine 48 is really annoying. What did you find, Krim? So I definitely wouldn't want to just use that as a fact. That is good to know that it has an actual value, though. I think the intention problem is that we have to do like work like this down here, though. So in terms of 36s and 18s, not sure what to do next. Well, what do they do here? They notice that 90 is equal to 2 times 18 plus 3 times... Is this what you're expected to do, Bio? This seems like it's going to be a little hard. And they're saying, it's taking theta equals 18 to... Like, so... do you think you're going to be expected to do something like this? Because it seems a little hard. You don't think so? So one from exam. Well, that's taking that sine square or sine 18 equals that square root thing as a fact, though, and I feel like bio doesn't have that as a fact. I mean, it's not something that bio was given. I doubt it was. Well, yeah, the teachers gonna wonder, like, what bio did. For multiplying. Really? Memorize the cosine, sine, tan for every angle from 1 to 360. Just to be safe, you might want to do it for every radians between 0 and 2 pi as well. Oh, they also just take the root 5 minus 1 over 4 thing as a fact here. It's a different problem. It's kind of funny that apparently the multiplication version of this problem is pretty commonly asked. I don't trust ChatGPT to do it for me. I trust Wolfram Alpha to get minus a half. Oh, we're in business. You're a useless fact. What is this? Oh, wait. Okay, they got to the same spot. Okay. This person, oh no. They're gonna derive the root 5 thing, aren't they? Oh, they... Hmm. This is the golden ratio? It's kind of funny. Yeah, but I think this is an incredibly hard problem. Wait, sine of 18 is exactly the golden ratio? No, that's not the golden ratio. The golden ratio is like 1.61. Okay, here's a completely separate way it seems. If you know that 18 degrees is pi over 10, which I guess is reasonable if you know that 18 times 20 is 360. So you do 2 pi over 20 is pi over 10. We're saying s is equal to sine of pi over 10. Why should we evaluate that? We're using numbers instead of pi. How do they get this? Oh, you take 4x plus x. Yep. I think this is the most reasonable way for you to do this, Bio, and I don't even get it. This is so much work to do. Like, this person simplifies it a lot. There's a lot of work in between the lines here. Oh, and oh, this assumes that you've gotten into the sine of 18 minus cosine of 36 form. So yeah, you have to get into sine of 18 minus cosine of 36. You have to know to write it in radians. And you have to note... Yeah, I'm sorry. I can't do this one, Bio. This is too hard. I'll link you to the Stack Exchange thing where this happens. I don't know what that means. Oh, Bio, be nice. Hey, Fire J7, help me with matrix equations. Depending on the equation, I can help. I think Grim might have another problem that I have to do first. Try their problem. All right. Yep. I don't know with this one. So fire J7, is that a to the power of 3x plus a to the 2b plus 2x equals, I don't know. Let me write what I think you're saying on the board and tell me if I'm right. Look at what Bode said earlier. Something like that. I just went and copy pasted Bode's chat history for those two. So, okay, fire. I said I feel like I'm interpreting your question wrong because I don't see where the matrix is. So is what you're saying the asterisk twice means elevated? So is it a to the power of 3x plus a to the 2b plus 2x equals a to b like this? Because I don't think that's solvable if it's like that. I don't know how you would solve it. Yeah, yeah, I don't really get the point of like problems like bioput. Like, just calculate it numerically. I mean, trig is super useful for computer science, but you would also just do it numerically and not have to simplify stupid stuff like that. So Fire J7, you're saying no wait, so I assume I am misinterpreting you. So if you're saying it's a matrix... Oh, what? Oh. Okay, so I'm still not completely sure if I'm right here, but the X is down there and the B is down there. Like that. Is it solving it for X or what's the goal here? This is a problem from the YouTube chat that I'm trying to see if I'm interpreting what Fire is saying correctly. Because I maybe have the equation copied down right now, but I don't really know what we're supposed to do with this. It seems like a whole mess. You definitely can't solve, you can't get just one number for A, B, and X with just this information. You could isolate X. In Fire J7, if there's like if English isn't your first language, you could try to put the original language in chat and I'll put it into Google Translate or something. So I'm not sure like what we're supposed to do with this. Basically Femvox, yeah. The Discord I don't monitor as closely when I stream, but I dual stream to Twitch and YouTube. I'm gonna type to FireJ just because I'm not seeing a response. You speak Spanish? Oh, okay. I wish I spoke Spanish. I'll type out what I'm saying too in case that helps you read it instead of listen to it. Oh, Anders is here. So yeah, Fire, feel free to say your problem in Spanish if that helps you. Um, hmm. To solve for x with solving as a matrix equation? Solve for x as a matrix equation. Yeah, it's in the YouTube chat. FireJ7, I'll copy this over to Twitch chat in case you guys have an interpretation of it. I don't know how you get a matrix equation with this. Like, we could factor the x out and just divide. Oh wait, I did solve a BOD a while ago. Oh, I think I get what. Okay, I get it. A and B are matrices. You weren't looking? Ah, shoot. All right, BOD. How about this? I'll solve another one. I'll clip it and I'll put it in the Discord. I'll write a note. Solve Rubik's Cube for BOD and send clip. If that's a Tesserines corrupt, I don't know. Okay, so solve the mirror cube next? I would need a mirror cube. Broadman just redeemed it. All right, well, let me prioritize the question that's on the board, but BOD, I hope you have fun with whatever you're doing. Okay, so if A and B are matrices, well, addition is still commutative, so I think we're allowed to subtract this over here. A cubed x plus 2x equals A times 2b minus A squared b. And it's still distributive, so we can factor the x out on the right, because these are both right multiplied by x. Oops. And then we're going to have the left multiplied by the inverse. I think that's how you would do it if these are matrices. Can you even give a genuine question? Yeah, apparently not corrupt. If these are matrices, Jed, the multiplication is not commutative. Multiplying on the left is different than multiplying on the right. So I think this is what you want, Fire J7. I'm not entirely sure though. Hmm. It's not correct. Hmm. Can you say what the answer is? Wait, that makes no sense. These are okay. No, I think two is in a matrix. Yeah. How does that work? So wait, are A and B matrices and two is the scalar? I don't know how to say that in Spanish. That might be too complicated. Um. Okay. I guess it would be. You could do the. No. Yes? You could say it's 2i. That might be the only thing that I did wrong. Maybe. Oh, yeah, FireJ. Look at the Discord in general? Okay. Let's see. Oh, God. I guess I'll bring this up on stream. No, I don't need to say it in Spanish anymore, Brownie Man, but I appreciate it. Okay, so we have this. Number 3. Oh, so we actually have values here for A and B. Is this down here different? No, wait, does this include the answer? Oh, you're saying for fun? Okay. Okay, so okay, this doesn't have. This is the actual question. 3 by 3, 3 by 2. Below is the answer? Oh, it's all the way down here. Where does C come from? No, it's further down, maybe? This one? Okay. Yeah, this is a lot of math that you would have to do. Oh, Gentle, you're saying, I guess you could pull a B on the right and pull an A on the left? That feels weird, though. A cubed and A squared are nice? Really, Ennis? I didn't get this, though, which makes you a little bit nervous. We're A and B again. Oh, okay, I guess A cubed isn't that bad to calculate. Hmm. Yeah, I guess you're right. Um, hmm. Okay. I mean, so I think we can use this. Let's see if it matches with what the answer should be. We don't have any powers of B, which is good. Because you couldn't take a power of B. 4 on 1. Okay, so it's matching? Okay, thank you, Fembox. So A squared isn't that hard to get. Can I do this mentally? Zero there. I think it's also a zero. Here we get a one though, right? Then we go there, which is zero. Go there, which is zero. Go zero. Zero. Oh, wait, this one has to be zero on the bottom. Okay, I think I did A squared right. And then A cubed. 0, 0. That one is going to go to 0 now. I think that's okay. I'm not blocking the problem? Okay, good. I should match the case though, right? I should have written them as upper. I mean, they should be uppercase, but I'm just going to match the work that I did above. Actually, I should just start. No, I'm overthinking it. Just start doing it with uppercase. Okay, so if A cubed is that, 2i, I mean, I is self-inverse, right? But if it's 2i, we'd want 1/2 I? I hope? Because 2002 times 1/2 0 0 1/2 do 1 0. Yeah, okay, so that is the inverse. Matrices are hard. Okay, so A times 2B. 0, 1, 0, 0, 0, 1, 0, 0, 0. 2B is 8 minus 4, 2, 4, 2, 0. Minus A squared we said is that. 0, 0, 1, 0, 0, 0, 0, 0, 0. B is the original, minus 2, 1, 1, 1, 2, 0. All right. See if this works out. 1/2, 0, 0, 1/2. Okay. This multiplication. Take that row, that column. Wait, what result? 3 by 3, 3 by 2. We expect a 3 by 2 result. Okay. So that upper left one is 2. That one is 4. This one's 2. This one is 0. 0. 0? Because that's all zeros on the bottom. Impressive mental matrix. Thank you, Gold. Fire, I'm sorry I'm doing a terrible job of explaining this. Especially because English isn't even your first language, so I feel like that's even worse. But once I know that I'm right, I'll go back and try and explain it more. I hope I'm right at least. So be a 3 by 3, that's a 3 by 2. Do that and that, so that's 1. You do that and that, which is 0. Do that and that. No, that and that. So we get zeros everywhere else. Okay. Wait. No. No, this is 3 by 3. Oops. Ugh. One half, 0, 0, 0, 1/2, 0, 0, 0, 1/2. 1/2, 0, 0, 0. I just realized that the matrix multiplication wouldn't have worked out, and I is supposed to be 3 by 3 this entire time. Do you need to write everything out? I feel like I'm making a mistake, but it's gonna be a lot of work if I write everything out, so. I know what the answer should be, and I'm banking on just doing it right the first time. It's gonna be 1, 4, 2, 0, 0, 0. We do have a lot of zeros in here, thankfully. Okay, one more multiplication, hope for the best. I feel like there should be a trick here when it's the identity in front, but maybe there actually isn't. Maybe it just is what it is. So you take that, multiply by that, so you get 1/2. Take that and multiply by that, you get 2. Take that, you multiply by that, you get 1. Take that, you multiply that, you get 0. Take that, multiply that, you get 0. 0. Okay, is it 1/2, 2, 1, 0, 0, 0? Let's find out. Oh my god, I did it. Okay. Somehow I got the right answer. Okay. So, Fire J, let me back up, because I did a terrible job of explaining all of this. Or tell me if you have a question specifically. Trying to think how I can say it in Spanish. Dices si hay una pregunta? Una pregunta? Actually, let me So I hope you're okay with this first part. Shoot. Yeah, actually, Fire J7 are you still here? You do the equation so that it's the same as in the answer. So it's the same as in the answer? Yeah, let's see if we can make it match more. So you want it to match more with this, which is fair. I don't know how you get that. Two to the I inverse is equal to a half I. And you multiply it out. Oh, because a cubed is 0. Oh. Okay. That's what you can't solve? Okay, fire. I think Jens over in Twitch said how to do it. So let me show. I think you do need to know that a cubed is all zeros here. Otherwise, you're just stuck with this. I feel like there's gonna be some commutative stuff happening there, which I'm not confident in. But if you know that a cubed is all zeros, then this does simplify. Because we know what 2i inverse is. Which is 1/2 I. Oh, I guess scalar multiplication still commutes. Is that the point? So now we can distribute the I in here. Oh, it's a weird noise. I guess that was a song. So it'll be 1/2. The 2 can come out front. Then we have IAB minus 1/2 IA squared B. And then 2 times 1/2 is 1. Identity doesn't change anything. So we have x equals AB minus 1/2 A squared B. So yeah, this is a bit easier to work with than what I did here. So I think with matrices, you're still allowed to pull that 2 out to the front, and that's why this works. But I think you do have to know that a cubed is all zeros to simplify it further. I'm gonna take a sip of water here. That was it? Okay. Well, thank you for the question, Fire Jade. If you have anything else, feel free to ask, and I can try to speak more in Spanish or translate what I'm saying more if it helps. But, yeah, thank you. Okay, so we have Rubik's Cube, solved from Brownie. I know, Crimby, you're still around by some miracle, and you solve a question. Feel free to ask. Okay. Oh, frick. Where the hell is that? Okay, there. Dude, all the edge pieces are hidden. This scramble is terrible. Another V perm, and I messed up the V perm? Oh god, this is even worse than the last solve. Hey, Central. Are you already done? There's no way. But thank you for the redeem, Brownie. Let me give this clip to Bode. What is Bode's name on Discord? I hope it involves Bode. Otherwise, I don't know what it is. Okay, good. Okay. Magic fingers? Mm-hmm. Tell me like, oh, do you do crosswords? I've tried to do them, but it seems like you have to really practice to know like what kind of patterns they tend to give clues about. I want to change the music. It used to be there's competitive crossword solving? I guess that makes sense. Okay. I guess I wouldn't have expected it, but fair enough. All right, so I don't think there's any questions from chat remaining, unless I'm mistaken. So maybe we'll finally get some studying? And I was thinking of doing multivariable calc. American Crossword Puzzle Tournament? Oh, wow. The next one's this weekend? Oh, do you still, like, follow it? Actually, let me take a minute to erase the board. Like, is everyone given the same crossword and you have to solve it in the fastest time? Or, like, how does the competition formatted? Come on. This is taking forever to erase. Okay, there we go. Oy. Scores based on speed and accuracy of the same puzzle, 7 puzzle for 2 days. Then find us for the top scores? Wow. That's crazy. I shouldn't be surprised that people do crosswords competitively, but it still comes as one, I guess. So yeah, for kind of like a downtime activity, I was thinking that I would benefit from reviewing some multivariable calc because I remember just like bits and pieces. But there's a lot of it that I've just kind of forgotten that I don't like. Or I don't like that I've forgotten it, so. People do one breath counting? Like how long, like how many numbers you can count up to in one breath? What? Do you just talk super fast? Can you share 600 people solving crossword puzzles in silence? Yeah, that sounds crazy. I've been to Rubik's Cube competition. My friends and I went when we were in high school. We're probably the oldest kids there. And I'd only just started solving Rubik's Cube, so my times were terrible, like 56 seconds or something. I think they barely made the cut. Like, if you ever solve take over a minute, I think they just say no thanks to you or something like that. Sneak inequalities from a visitor to your stream they weren't able to solve. Oh, they might have posted it to my Discord too, and I have no idea how you do them. I think Bo was able to do them, that person said. Those are like, I assume they're competition problems or something, because they seem to take tricks that I've never seen in my life. Arithmetic mean versus geometry mean. Okay, yeah. So yeah, Bo told me like a little bit about that. They seem kind of hard though, and like the other ones with functions I thought I might be able to figure out, but I got nowhere fast when I tried to actually like think about it. Oh, excuse me. But either way, I think I'm okay just studying multivariable calc because it's something I really do want to remember better. And so I'm forcing myself not to just skip to the fun stuff like the triple integrals. I feel like there's like basic things that I've forgotten too, so I'm at least trying to skim the more introductory stuff. Like if you have a point in like, okay, yeah, how you define a line in 3D space with a vector, like stuff like that. You parameterize it with t, I guess. The vector addition on this is kind of weird because like your R0 vector, like it would be like your y-intercept, but with vectors here, like it points in a completely different direction than the actual resultant like vector goes because of the way that vector addition works. Wait, but if t equals 0, then you do get that same vector back. So is it changing? I guess it would be changing direction in magnitude. Really? Half-dimensional? I think you have to define what a half-dimension is. For some reason, I always imagine this as this is becoming so uncomfortable. I thought you maybe no, maybe I'm just wrong. Because I thought you would travel along like this is your angle, and you just travel further or shorter along that same like angle. Like this is a terrible way of describing it. I feel like I want this like really visualized. Will Desmos do this? Because I've been visualizing these wrong, I think. True, like these pulse notes sometimes. I really like the site. So let's say we have a vector 1, 1, 1 plus, well, I guess t is just times vector, and let's say our slope is like -1, 0, 1. Will Desmos know what to do with this? No. Ah, well. Mangoes, necessity for every calc student? Yeah. Oh, you know what? Mangoes, you might be happy to hear that I actually am studying a little bit of abstract algebra. There's a reading group that another math streamer is doing, and I've been like trying to read along and like keep up with it. It's only like just started though, so we like only just got to like introducing group theory and stuff, but yeah. Vision line passes through these 2 points. Okay. So yeah, right now I'm just doing some like multivariable calc review just because I feel like I've forgotten way too much of it. Yeah, I mean, it helped me. This site helped me a lot when I was doing calculus this in Wolfram. And like for everything that like, if there's a, I mean, the algebra stuff is a little bit weak, but like calc 1, 2, 3, and diffie-qs, it's like I love all of these sections. Oh, you closed the window? Oh, no, no worries. You might be happy to hear that I've been starting to study abstract algebra a bit. There's a reading group that another streamer is doing, and so I've been trying to like keep up with it. So it's only like super early on. We're just like introducing group theory now, but yeah. I don't know if I'll be able to like keep up with all the stuff that you know though, but you know, maybe I'll get a little bit closer. Group springs and fields. Yeah, so I just read like, because there's like chapter 0 preliminaries, which is like a bunch of like number theory stuff I should probably go back and do more of, but we just got, or like I also just read chapter 1, which is like, it talked about like dihedral groups of order 2n or something like that, and like with like a square that you can like flip it, rotate it, and stuff like that. I don't understand how it's going to be relevant, but I assume it is. So, we'll see. And I don't mean to keep you if you're trying to like go somewhere else, but because let v be the vector that starts at the second point and ends at the first point. All right, so you get the slope just by subtracting these two. And then you can use either of the 2 points as your starting vector, I guess. Wait, starts at the second point, ends at the first point. Actually, I was gonna skim this, but maybe I need to actually read this a bit more because I'm kind of glazing over some details that are probably important. We need the vector v that will be parallel to the line. And if it's as long as it's parallel, v won't lie on the line itself. In this case, it will. I assume this is arbitrary, and you could do it the other way. And the line, the vector between them will be parallel to the line. Okay, yeah, so for some reason the phrasing of that was like confusing to me, but it's what I thought it was, and I was just making it too complicated. So they took 2 minus 1 is 1, negative 1 minus 4 is negative 5. Okay. Hey, Brian, math? Yes. That's the answer. Nope. Okay, and they do so we could have just easily gone the other way. This form feels a little awkward to me. I mean, I guess they're about the same. Okay. So this is the procedure that I thought it'd be, but for whatever reason, actually seeing it written out was weird. Okay, yeah, I think there's multiple solutions to this problem though, because your vector could be pointing like there's gonna be like a positive direction and a negative direction, and it doesn't matter which one is which. I think. This is stuff that I would just like skip over and assume that I know. It says love or always. Parallel to this line. So here you'd only care about. Would you see now? This is where I think you'd only care about the coefficients of t. But I thought I just said from the visualization above that this vector is changing direction, isn't it? some... Numbers multiplied by t at the coins vector that is parallel to the line. You do just... Okay, so maybe my instincts are right. I've just been doing this... So... maybe it's not changing direction. So I was going to look at some visualization here. So, Brian, this is just me like trying to go back and study like multivariable calc, just starting from the basics and not skipping over things like I am normally inclined to. And so just like the, I guess, vector form of a line, like this, I was thinking, because of the way that vector addition works geometrically, is this just one line or is it changing direction? Like I was getting a little confused on this because I guess it's always the same. If this, okay, so this R0 is always the same vector, but if this A is increasing or decreasing, isn't the resulting R, like, it's moving, I guess, in a line? Oh my god, they actually draw the line for you and I just didn't realize it. Yeah, no, it's just... Okay, how about the... I guess it depends on your frame of reference, because this R vector here, it is changing both magnitude and direction, but that does form a straight line here. Okay, so that's what I was getting confused on. It's weird to me that this thing R represents this red line here, I guess. That's what I was getting stuck on with the visualization. And hey, Daniel, our help change directions. Okay, yeah. That's where, like, that's kind of a weird concept. Define something by non-commutative addition? Oh, I bet you could. Corrupt. Yeah, so I notice how it's like y equals mx plus b, but it's... Okay, and I guess this R0, it's your starting point somewhere on the line, and then the slope here is how far along that line you go. It's just like, I don't know, this resulting R vector is just like weird, that it points to the line from the origin. It's probably not like that important of a distinction. I can think about it just as this red line here. Watching math videos in the algorithm, randomly recommended your channel. Oh, hey, well, welcome in, Daniel. See, my normal kind of shtick is I take people's homework questions if they put them in chat, or sometimes I'll look around online. But if things are slow like they are right now, I just kind of go back and like study things that I want to know more about. So I'm looking at like the introductory stuff for multivariable calculus. And I'm forcing myself to not just skip over this introductory stuff and to go back and like remember and understand it more, because I would normally just like say we're going to go straight to the fun stuff, like the triple integrals that I enjoy so much, but not yet. Because there's only some basic things in multivariable calc that I just can't even remember for the life of me. So like this, apparently, with how the vector equation of a line actually works and why it actually works. Corrupt, you wanted to find just like the most annoying type of math? that'd be kind of funny. Yeah, no, it's kind of a weird concept that like the line doesn't change direction, but the vector pointing to it does, which it does make sense now that I have made that realization. But you think of a line as not changing, and so I apply that same not changing thing to the R vector that points to it, but that's not proper. If you have meat to bread, you get a sandwich. If you have bread to meat, you get a meatloaf. Truer words have never been spoken. Yeah, that's a great example of non-commutative addition. You need two cosines and three variables, or three and four variables. Right. Shoot pictures in Microsoft Paint, not sure how to post it. I mean, I think I feel comfortable with this concept now, but if you want to post a picture, or if you still post and think it might help, I do have a Discord. But barring that, I don't think there's an easy way to post pictures because links don't work in YouTube, I don't think. Unless they're from a mod. I don't remember how that works. It's true in 2D as well. The line doesn't change direction. Oh! Okay. Yeah, that's a nice point, Brian. You're right. That would absolutely still be true in 2D. So we never really bothered with that representation of it, I guess. And this is what Daniel posted here. R is the blue bit vectors, right? Yeah. So this is actually yeah. I guess it's not. That's it. Just reminding myself of that because I'm sure I understood this at one point when I actually was taking multivariable calc, but it just feels a little bit weird, I guess. Yeah, so like I was thinking like you know, like the geometric interpretation of like vector addition is like it's not the result of the vector that is your line. Well, it kind of is. I don't explain it right. I think I understand it, but it's like I was thinking like, oh well, here, you know, R is that vector, but then over here R is that vector, so those aren't going in the same direction. So I was out of line. But of course, the line is the right thing up there. So, but thank you for the drawing, Daniel. Yeah, right. Maybe I was also thinking of linear algebra, where you always take things as coming from the origin. Or at least in the class that I took. Maybe there's more advanced linear algebra where you don't. The origin, we can see it doesn't change direction. We treat it as multiplying. Yeah, right. Okay, and so for this parallel line problem, that's why this whole like just taking the coefficients of t is okay. And then you can really just take the point that they give you and slam them together, and then I think you're done. Determine if the line passes through the xz plane, and if it does, give the coordinates of that point. So for the second part of the question, you take y equal to 0 and solve for t. You can find that happens at 1/4. Okay. Oh, you're trying to define your non-commutative addition? I don't know either. One dimension in 3D, right. So now for planes, you need a vector that points anywhere on the plane, and then a normal vector that's perpendicular to the plane. That's kind of a neat form of writing it, the dot product. This I feel like I remember a bit better than the equation of a line. Because yeah, A, B, C are the components of the normal vector to the plane. Come up with random ass rules and make something work with them. Yeah. The bullshit numbers, there you go. Determine the equation of the plane defined by these 3 points. And so I believe to do this, you would choose one of these as your starting point and then subtract out the other 2's to get 2 vectors. You would take the cross product of those vectors to get your normal vector. Ooh, do you have to... Does its magnitude need to be 1, or does it matter? I doubt it matters. Nope. Okay. Yeah, that's definitely magnitude more than 1 there. So actually, yeah, because you can multiply each side of the equation through by something and not change what's actually happening. Not naming your theorem's big dick theorem. I mean, on Saturday, we were going down a rabbit hole of dirty sounding math things. There's a real thing in math called the Cox-Zucker machine. It has a Wikipedia page and everything. So there you go. And it was named specifically like for this whole, you know, so for the future that corrupt doesn't get there. Yeah. For the sake of math. Okay, so yeah, I feel like I remember the process for getting the equation of a plane from 3 points well enough. Determine if the plane given by that and the line given by that are orthogonal, parallel, or neither. So you would take the normal vector for the plane, you would take the slope of this line, you would do the dot product and divide by each of the magnitudes and do the arc cosine to get the angle between them. And that'll tell you everything you need to know. Oh, or you just cross product them? Exploring theorem of all math and physics. Corrupt converters, big dick theorem. I mean, yeah, if you make the grand unified field theory or whatever it's called in physics, I think you should get to name it that if you want. You know, just like Fermat's little theorem, Fermat's big theorem. Is there a Fermat's big theorem? A Nobel chemistry prize for the single lonely alcohol property? Oh no. Oh wait, can't you just see if they're scalar multiples of each other and that... Oh no, because the normal vector is perpendicular. Well, I mean, if they are scalar multiples, you know that they are perpendicular then. Right. So why are they cross-producting and pointing them out? Is the cross product of 2 parallel vectors 0? I guess that makes sense. Oh, really? Fermat's last theorem is the same as Fermat's big theorem? Great theorem? Last theorem? Oh, this one. Is this the one that he said that like he found a divine proof for, but the proof is lost to time? Right, yeah, this one is it. Is it still unproven? Oh, Andrew. Okay, no. I feel like I've seen this fact before. Can Upfield allows a troll? He proved thousands of theorems and the haters get on his case. Oh, that he didn't really know how to prove it? It's proven with math that didn't exist back then. Oh, really? Okay. And about cross sections and calculus today? Oh, cool, Jacob. If you're doing cross sections, are you maybe doing like multivariable calc, or are you doing like solids of revolution? Actually, I guess cross sections could be a few things, right? Just since Fermat made a mistake on that one. Oh, okay. He almost certainly didn't. Ooh. Solids of revolution. Oh, cool. Those are both fun and kind of annoying. It depends on the actual problem, but if you have a problem that you want help with, please let me know. But if you're here to hang out, that's completely fine too. With adding something that could be wrong. Thanks for the follow. Wow, it's in the Guinness Book of World Records for the most difficult math problem? Okay. Good to know. There's a lot of interesting like characters in the history of math, like Fermat just casually doing amazing things in the margins of a book, and he's not even an actual like being a mathematician wasn't even his day job. Hey, Lo, how's it going? Let me get a cop drop. It's going good too. Just since things are a little bit slow from the questions, I'm just doing some studying. He died in a duel? All right. Ah. Okay, we can get to Fermat through this page. Galois was killed in duel. Oh, okay. How did Fermat die? Oh my god. Could he be making a nicer face? Actually, it's a little bit... Okay, I thought his mustache was his mouth. Never mind. He still looks a little angry and a little cross-eyed. He looks so... Okay. I don't know if I'd want the statue to be of me. But... Yeah, he himself was like he's eating up too much. Galois died at 21. $57. Okay. Just looks like a regular dude. I mean, aside from the long hair. Yeah. I mean, people have generally looked like regular people throughout history, I think. It's just like the representation of them. Wait. Or there are something to say so to a lot of people? Yeah. I don't think people should be judged for that. You see them with the Instagram filters? Yeah, you know how like people will like take black and white pictures and colorize them to make them look more modern. I wonder if people are going to use like AI to do like, you know, modern day like selfies, you know, of historical people, you know, for Matt making like a duck face or something. Would Fermat be a TikTok star in today's time? Probably not if he makes math TikToks. As Barney? Maybe Fermat can trick, maybe. I think of Barney the dinosaur. I don't know if that's what you mean though, Brian. What is the cross product equal to again? Like the sine, it's something times sine of something. Like why? Like when the cross product equals 0, it means that sine of theta equals 0, which means the angle between them is 0. Okay. So it means they're parallel if they are 0. In the case they're not 0. Okay. If you got something that wasn't 0, you divide by the magnitudes. No, it has to work when it's cross product though. Oh, there's the extra n there. Yeah, how do you use the cross product to find the angle between two vectors? I would normally use a dot product for that. Purple dino format, yeah. The area of the parallelogram. Right, but if it's... I guess I'm wondering if it's a square, how is that represented in the result of the cross product? Like if they're perpendicular. It's like sine of theta is just a scalar, so... Actually, I guess I'm trying to figure out why Paul's notes is using the cross product rather than the dot product here. Because if I want the angle between two vectors, I don't like if you're just given two vectors, I would always think to use cross product if I want the angle between them. I do know that, like, you know, sine theta is involved in the cross product, but how do you actually isolate theta? I can't figure out how you would do that. Or like, how would you solve that equation for theta? It seems like it's not really possible when things are vectors. I mean, I guess you could divide the elements as uncomfortable. Like, sine theta would have to equal like whatever the ratio between the elements is. It seems like an awkward way to do it. Oh, really? That should be the magnitude of A cross B? This equation? Okay, that will make it much simpler. Let me see if a different site gives it in a way that makes more sense then. Are you sure? Oh, wait. They're giving it in vector form because of the extra n vector. But it might also be true if you take the magnitudes. Oh, okay. Then I'm okay with this. And on top there, it's the magnitude of A cross B. Right, Brian? So that's what I was getting, like... Okay, well, this is not good notation. Okay. No, it's all good. I'm trying to make sure for my own like understanding that I know what's happening here. Okay. So yeah, I guess using the cross product is I still feel like the dot product is easier, but I guess there's nothing that's wrong with using the cross product. Um, okay. Oh wait, so then they do the dot product. Oh, okay. Maybe I should have looked at the rest of the solution too. They're using the cross product to check for orthogonal and the dot product to check for parallel. All right. Oh, frick. I forgot to charge my phone. 1 second. I guess I don't really need the whiteboard for now, but I use my phone for the big camera for the whiteboard. And normally I put it on the charger before I stream, but I forgot to do it today, so I'm gonna let it charge for a bit, and there'll just be a black screen in the background for now. Okay. Now these I definitely don't remember that well, like types of three-dimensional functions. Playing football with why is he charging it? Ellipsoid, fair enough, like a normal ellipse, but also z is in there. A cone is if whatever has the negative sign is what the cones are parallel to. Oh, they count ellipses as cylinders? Okay. Hyperboloid. Oh, it's like a cone, but you have a constant term in there. Okay. Hyperboloid of 2 sheets. What's the difference? The signs are reversed? Okay. I'm definitely not going to remember that. I'm probably not going to need it, though. Elliptic paraboloid. The power of z is just to the 1. Hyperbolic paraboloid. Oh yeah, I feel comfortable enough with that stuff. Vector functions. So I'll slow down a little bit more for these. So I guess the domain you would take kind of the most restrictive domain of all of these. So from this one, t is greater than 4. T can be anything. And t is greater than -1 or equal to. So I think our overall domain is t is greater than 4. Wait, I have that backwards. It's 4 minus t. So yeah, it should be from -1 inclusive up to 4, not including 4. Yeah, the intersection of domains is a good way to say it. Fan domain is such a dumb question. Are you saying that because it's like the reverse of how it should be, Yanis? Because like I know what the question means with saying like, you know, given the normal definition of ln and square root and cosine, I guess, what values of t can you normally plug in? But I guess I don't see what's wrong with it. T comma 1. Y is equal to 1. X is equal. Isn't that going to be okay, wait, so this is a vector in R2. It's going to be a constant function y equals 1. Yeah. Okay. This one, this is just a cubic. That's going to be, yeah, it's going to be like a normal two-dimensional cubic, but because we're in 3D, it's going to be like projected, I guess. Yeah. Oh, actually, no, it's not even in 3D. I saw there was a 3 there, and I was like, oh, 3D. It's going to be an ellipse. The domain is part of the function. You can only have a function without the domain. Oh, it's commonly done. That, yeah. That is, I guess, like a very like different kind of way that higher level math is done. Do main, that is a program with E. It sure is. Got a main method, got a do while. You always get a C in math. Is there a pun in there, or are you just actually like saying that? Oh, because to see the language, right? See, well, there we go. Okay, I got there in the end. The limit of a vector function, you just do each limit of each of the 3 individually. Wait. You can do L'Hospitals on this limit? I don't like that. Hey, existence, you got an F sharp in math? Nice. That's really good. It means you're a sharp student. I feel like you should be able to do L'Hopital Loma. I guess it's technically different though, since T-1 in the bottom. Actually, no, it really is. Oh, it's Daniel? Okay, nice. Because it's sin x over x. And you can't do L'Hopitals with sin x over x. You'll never get a high-paying math job. Some people... Okay. I will do whatever I'm told with sin x over x. I just want to be told one thing, okay? I've heard they specifically can't do L'Hopital with sin x over x because you haven't proved what the derivative of sin is until you evaluate the limit of sin x over x. I'm happy to do whatever people say. I want to be told one thing though. Everyone else argue it out, okay? Hey, Obi. Let me see if my phone is back to being able to be awake now. So I've had people tell me both sides of that, and I don't understand. I'm like, what's what? Thank you for the follow, existence. So you guys feel free to like argue it out, I guess. Oh, okay. I was wondering if it would like come back up immediately. 1 second. These are getting behind the scenes of how I set up my whiteboard right now. Okay. How does that look? That's not the worst. I'll keep it like that. Okay. If you're proving sin x, or if you're proving the derivative sign, you can't use L'Hospitals. I don't know. I've heard the opposite. I don't know enough to say for myself. So hey, Stuki. Um. Okay, you know what? I'm already getting bored of this introductory. I'm going to triple integrals. I want to do a triple integral. It does existence, and that's why people say that you can't use L'Hospitals with it, because it's considered, or is they considered to be circular logic. Actually, can we I wonder in spherical? Oh, okay. Oh, he doesn't get. Actually, I never looked at the assignment problems for these. I didn't realize that the solutions aren't given out, but I'm sure that we can figure it out. Let's try this one, because I'd never done the assignment problems before, so I figured I've probably done the other ones before. I guess let's just do number one. So we're going to be working in spherical. I need to get the conversion formulas up. One second. Okay, I have them up. Oh wait, what's the problem again now? Okay, triple integral 4y squared dv. Where E is sphere. Okay. That's, I wrote like, I don't know what it's supposed to be. Okay, there. You're being purposefully silly. Oh, no worries. You need a better whiteboard. How much do you need? Oh, I mean, honestly, like, I don't really mind the whiteboard itself, besides, I guess the erasing part is annoying, but I don't know if that's the whiteboard or the eraser or what. It's big seem as infinity's not a number. I don't know, yeah, so I just want to be told one thing with that stuff. I don't care. Also, the thing about most of the whiteboard is to actually screw it into the wall, but I'm a renter, so it's not going to be in the cards for me. If we want to convert that into polar, the dv is going to convert into something as well. Yeah, rho squared sine phi. Okay, so y is rho sine phi sine theta? Really? Rho sine phi sine theta? Okay. Or rho sine phi sine theta. Oops, not yet. Rho squared sine phi. We'll say the order probably doesn't really matter that much. So d rho, d phi, d theta is usually like a default order, I feel like. And actually, no, it's usually d theta, d phi. It really shouldn't matter if we're doing a sphere and spherical, though. I mean, maybe it's also just where math becomes philosophy, and 90% philosophy I just don't really care about personally. All right, so rho here is going to go from 0 to 3 because the sphere's radius 3. Theta is going to go 0 to 2 pi because it's an entire sphere. Phi is going to go, phi is defined from minus pi over 2 to pi over 2. I should verify that, right? Phi is 0 to pi. It's measured from the negative y-axis, or z-axis. Okay. Or no, from the positive z-axis. Okay. God, glad I looked that up. So like the azimuthal angle, that's what? X, Y, Z. V is like that angle there, which feels weird, but I guess it's fair enough. Then like theta is like the angle in the XY plane, like a normal unit circle angle. Okay. So I think that's our setup for the triple integral, and we just go through with the actual integration now. Physical aspects of math are generally your favorite? I mean, I think you'll be in good company in chat then. Just when stuff gets I mean, in general, when stuff starts getting too philosophical, I just kind of stop caring. But you guys are more than welcome to discuss it if you would like. The 4 we can bring all the way out front. We have rho cubed, which will integrate to a fourth row to the fourth. Oh, they even make that work out nice with a fourth and a fourth. Wait, it's rho to the fifth. Ugh. Because that's rho squared times rho squared, which is rho to the fourth already, and then you integrate it to rho to the fifth. There we go. We have sine squared phi sine theta d phi. Okay, the 1/5 can come out front. Three to the fifth. Oh God, who knows that? It's gonna be 2781 times 3, 243. Okay. God, the wool waist sweatshirt. Sorry, my headphone cord is getting tangled. 243 times 4. I'm not brave enough to do mentally right now. 892. Well, we're entering theta next, so sine integrates to negative cosine? Cosine of 2 pi is positive 1. Cosine of 0 is positive 1. So it's negative 1 minus 1? Nope. Minus negative 1, which is 0, right? Because cosine over entire period should integrate to 0? Okay, that's probably... Wait. That doesn't make any sense. We shouldn't get 0. That seems like a problem, doesn't it? Do I not know how to... Is it 972? Oh my God. I can't even do the math like correct physically on the board. Now, what's my problem with the cosine? Thank you, existence. Oh, it's sine squared. Not just sine. There we go. That's my problem. I dropped the square that was there. If you want to integrate sine squared, I think you got to do 1 minus cosine squared and then do a half angle. Double angle. One plus cosine. Oh wait. Oh yeah. Oh, actually, this format sheet gives it to me off the bat. 1 minus cosine 2 theta over 2. Then we know how to integrate that with theta now. It's going to be theta over 2. Cosine integrates in positive sign still. Like that, I want to say 0 to 2 pi sine squared phi d phi. Probably. I think I used up all my mental arithmetic energy on doing that matrix multiplication earlier in the day, and that was my problem. All right, theta over 2, plugging in 2 pi, you get just pi. Sine of 4 pi is 0. 0 over 2 is 0, sine of 0 is 0. So you get just pi. This is one of those funny calculus problems where if you just like use the geometry formula. Actually, no, never mind. It's 4y squared. Never mind. Sorry. There are some like most variable calc problems that are just like, you know, find the volume of the sphere and there's an equation for that already, but this one does have something inside the integral which makes it different. So sine squared we said is equal to that, which integrates to that. Actually, so we can just use the same exact result for the integral, but with phi. Get pi over 2, sine of 2 pi is 0. 0, 0, so we just get pi over 2 out of this. So the 2 can cancel with a 972, which will be 4, 6, 6. No. Come on, I can do this. 972 divided by 2. I shouldn't need to, definitely 4. You have 17, which is 8. Goes into 16, 1, 12, 3. Not 3. That should be 6 if it's 2. Is that right? 12, carry the 1, 16, 7. I think this is right. 486. Don't we have sine cubed to phi? Oh no. Oh my god, you're right. Because that's sine squared and that's, oh my gosh. Thank you, existence. Oh, no easy tricks for me that time. Goodbye, eraser. Hardly knew ye. All right, I gotta integrate sine cube. That's much more annoying. Actually, no, it's not. It's less annoying. Because we pull out one of the sine phis. You do 1 minus cosine squared phi, d phi, and then you do u equals cosine phi. And then you're home free. It's actually even easier than sine squared to me. It's less memorization. Sine phi cancels, you get a negative sign in front. Actually, instead of doing a negative sign, I'll just reverse the order of subtraction, so we get u squared minus 1. du, which we know how to integrate, 972 pi over 5 is 1/3 cosine cubed phi minus cosine phi, 0 to pi. Let's hope that works. So cosine of pi is -1. -1 cubed is -1, so you get -1/3. Plus 1. No, yeah, plus 1. Minus cosine of 0 is 1. 1/3 minus 1. Oh. No, these add, not subtract. So 1/3 minus 1/3 minus 1/3 is minus 2/3 plus 2. Ugh, fraction math. I'm bringing it all the way home though. 6 over 3 becomes 4 over 3. So that becomes positive 4 over 3. Does 3 go into 972? It does. I still have to multiply it by 4 though. Okay, then cancel 3 with that. 3, 1, 4 over 5 pi. 4 times 3, 14. Hey, 3, 14, that's like pi. 1200 plus 4 times 14. 4 times 14 is 56. 1256. Let's see. Let's put this baby into Wolfram Alpha. No, Wolfram, I hate you when you do this to me. Okay, you're gonna work now. Thank you. Four. I mean, no, never mind. Sine. Where are you, phi? There you are, phi. Sine theta squared times rho squared sine phi. Then I said d rho, d theta, d phi. Come on, give me the same answer. 1296 over 5. Did I do the final step wrong? 4 times 314? No? I did did I do the cancellation wrong? And 72 over 5 minus 2/3 plus 2. Just give it that step there. 1296. Okay, so I did my fraction math wrong, evidently. What is 972 times 4? 3888? Oh wait, no, I got a cancellation first though. That's 972 over 3. 324. I said it's 314. Ugh. All right, well, that's close enough. Okay, no. Actually, I did all this work. Well, let's get the exact right answer on the board, and then I'll be happy in life. So that instead of 314, it's 324. It's 1296. There you go. All right. Oh. I do like triple integrals. That one was a little bit more of a pain than it was fun, though. The setting up of triple integral, I think, is like the more fun part, to be honest. And trying to like visualize things and, you know, figure out kind of like the, I guess, like high level strategy with changes of variables and stuff. But the nitty gritty of it is really easy to make an arithmetic mistake on. Spin it since we had a question from chat. I think I might kind of wrap things up for the day. Because I'm starting to get a little bit like mathed out, so. Just kind of checking things out. Yeah, I think I'll wrap things up. Something cut out the YouTube stream. Goodbye, YouTube.